Welcome to Naraxon's tutorial for performing a jump analysis in MR3. In this video, we'll go over the MR3 software workflow for collecting jumps, protocols for each jump type we can detect in MR3, and a basic report overview. There are 5 types of jumps we can recognize in MR3: the counter movement jump, squat jump, drop jump, broad jump, and hopping. And for each jump type, there's a specific protocol to follow to ensure the jumps are correctly detected in MR3. For all jump types, the following workflow in MR3 must be followed. Select the configuration from the Home tab and activate the measurement without any weight on the force plates. The force plates are automatically zeroed during activation. The athlete's body weight is measured when they're standing still either at the beginning or the end of the measurement. Instruct the athlete to stand still for a few seconds after starting to record and before the athlete begins jumping. Lastly, wait to start the recording until the athlete is on the force plate and ready to start the test. MR3 will recognize up to 7 phases in a jump, which includes short pre- and post-stabilization periods before and after a jump. This chart clarifies how the jump phases are detected in MR3 and points out the phases that are detected during each specific jump type. Now we'll go over the protocols for each jump type and point out how they relate to those jump phases. During a counter movement jump, the athlete must remain still prior to movement onset for at least half a second. The counter movement jump begins with a downward preparatory phase completed immediately prior to the upward concentric phase, which concludes in takeoff from the ground. This type of jump assessment is applicable to many sports as it incorporates the stretch shortening cycle. You can perform one or more jumps in a single measurement, but be sure to pause between the landing of one jump and the start of the next jump for accurate detection of the onset of movement and stabilization periods. A counter movement jump begins with an unweighting and braking phase prior to propulsion before concluding in flight, landing, and stabilization. During a squat jump, there is no counter movement or eccentric preparatory phase of the jump. This type of jump requires the athlete to hold a squat position, then explosively jump from the held position. This type of jump is used to isolate the concentric portion of the vertical jump. As with the counter movement jump, the athlete must pause between jumps for accurate detection of the stabilization and movement onset. The first phase of the jump detected for the squat jump after pre-stabilization is the propulsive or concentric phase. After that, it concludes in flight, landing, and post-stabilization. The next type of jump is a drop jump. The drop jump involves the athlete dropping from a predetermined height, landing on a force plate, then immediately jumping in a vertical direction and landing a second time back onto the force plate. This jump assessment is used to quantify the reactive capabilities of the muscles. Key points of the drop jump to remember are to fall from the predetermined height, not jump off, land and take off with both feet at the same time, and after landing, stand still on both feet for at least 1 second before stepping off the force plate so body weight can be calculated. The jump phases detected for the drop jump include the braking, propulsive, flight, landing, and post-stabilization phases. Broad jumps can be detected in MR3 when the athlete starts off the force plate. This jump type requires the athlete to jump forward from a standing position and land on the force plate. Broad jumps are commonly used to assess horizontal jumping capabilities. Remember to instruct the athlete to stand still for a moment after landing. Since the athlete starts off of the force plate, the weight will be calculated after landing. In MR3, you can quantify landing capabilities from this jump. For hopping, no stabilization phases between jumps are needed. The athlete will jump continuously and only the propulsive, flight, and landing phases will be detected. Jumps may not be accurately detected in MR3 if the protocols we mentioned are not diligently adhered to. Staying consistent with your protocols and workflow in the software will ensure the jumps are calculated properly, and most common jump analysis errors can be avoided. Some of the most common workflow-related errors occur when the athlete does not stabilize after completing a jump or before movement onset. For example, if the athlete adjusts their position by shifting their weight back and forth without stabilizing, the stabilization phases will not be detected for the jumps. If this happens, while running a report, the software will notify you that it's missing the stabilization phases and instruct you to remove the jump. It's important that these jumps without adequate stabilization phases are removed from the analysis so impulse-related metrics are reported correctly. The stabilization phases influence the weight used for the impulse-related metrics. The next common error occurs when the body weight phase in MR3 is not detected before or after a jump. If the athlete does not stand still on the force plate for long enough prior to jumping or after completing their jumps, none of the jumps will be detected in MR3 while running a report. Body weight is calculated as the mean value of the vertical force over a half-second interval wherein the vertical force stays within plus or minus 5% of the mean value. The next common error is related to starting a measurement in MR3. When you enter the Measure tab, a message that says Activating Hardware will appear. The force plates are zeroed while the activating hardware message is present. So, if the athlete is standing on the plates while they are activating and zeroing, their body weight will also be zeroed and no jumps will be detected. When this happens, the vertical portion of the force curve will show body weight at 0 newtons and flight as a negative force. It's also important to only perform one type of jump per recording. MR3 may detect phases of a different jump incorrectly if more than one jump type is measured in a single trial. After you've collected your jumps, you can run a report. While viewing the record you want to run a report for, choose Report from the green action bar at the top of the screen and choose either the Jump Analysis or Advanced Jump Analysis report. The jumps will automatically be detected by MR3. To get a closer look at the period definition for any of the jumps, you can highlight and zoom in on one of the jumps. Keep in mind that the phases detected for each jump will be different depending on the jump type, as we went over in the beginning. In this example, we're running a report on a counter movement jump. When you're happy with the jump selected, choose Next to run the report, and you'll see our generic jump report template. You can see that the jump type is listed at the top right of the report. Jump parameters will be shown at the bottom of the report. You can add additional parameters by double-clicking on the Force Parameters element and enabling more parameters from the list. Aside from adding parameters, the jump report template can be further customized to fit your specific needs. For any questions related to the jump workflow and analysis, please reach out to support@naraxon.com.